So we're going to take a deeper look at the stack data structure. And the stack, it works just like it sounds, like a stack of objects. So we're going to take a look at an example with dishes. So if we take a look at a stack of dirty dinner plates, in order to wash them or to get to any of the plates at the bottom, you have to take the plates on the top, or all the plates that are on top of it, before you can get to it. Okay, so for example, I may want to get to one of these plates down here, but in the stack data structure, I'd have to move one plate at a time in order to get to the plates I wanted to. Okay, so I'd take them and set them aside for me to get to the plates that I wanted. Okay. Now, this is why stack is referred to as a last in, first out data structure. So the last object into the stack, or at the top of the stack, is always the object that we need to take first out, or remove first. Okay? And the stack has really three primary methods or functions for operating on it. So as opposed to having different types of additions or deletions, we really only have three in order to add and remove our elements of our stack. Okay? So moving on to take a look at the first method that we're going to perform on our stack, and that is the push function. And it forces an item onto the stack, or places an item onto the stack. The new item becomes at the top of the stack. So no matter how high it is, our new one is always on the top. We can't slide any in the middle because it's last in, first out. So it should make sense that our stack structure will keep track of what item is on the top. So for example, if we place a plate onto this MyStack data structure, okay, we're going to need to keep track of where the top element is. So I have a variable here called top, and it would point at the top element. Okay, and now if I take a look at adding another plate on top of my stack, we're going to have to change where top goes. So instead of being there, we're going to have it point to our second one. Okay, and so on and so on. So as long as I continue to add plates or items onto my stack, I'm going to have to continually have the top pointer point to the one or the plate on top. So after all those additions, we would have top pointing to our plate on the very top of my stack. Another function that's very important, obviously, if we're going to be able to add function or add plates or add elements with the push function, then we would also want to be able to remove items. And since it's a last in, first out data structure, we can only remove the top item. So in our example below, top would be pointing at the plate right on the top. Okay, and we're going to have to force or remove the plate off of the top. Okay, so what's going to happen is we would call the function pop, and it would then remove the plate on the top and get rid of it. At the same time, we would have to have our top variable change to be pointing at the new top. Now, one thing that's important to note is that I've said the item is also returned. And what that means is, in a main method, if you were to call myStack.pop, it would return the object, or it should return the object as well. This means that you can actually get the object and hold on to it. So in this case here, this is the plate that was popped off, and you get it returned to you from the function. But it's also removed from the MyStack data structure. The last method or function we're going to look at is the peek method, and it returns a pointer to the object at the top of the stack. So this is basically like looking at this stack and being able to only see the top object, but we can see it and we can grab it. So we're able to do things like, if it was a number, to change the number from a 4 to a 5, or in our animal object example, we could change the name of the animal, or we could change if it had a height variable or a weight variable. We could change or alter that object or element because we can get a pointer to it, which is just like being able to hold on to the object, but without actually removing it from the stack. So it hasn't been taken away from the stack. This might be useful not to necessarily change the item, but if you wanted to, take elements off until you got to a certain point. So if we had a certain plate we wanted to get to, we might say, well, keep looping and keep removing elements from the stack until I get to the one I want to go put one on top of.